So this is actually going to be notes for section 2.3, but there's a little bit of an introductory before we get to the 2.3, and that is I need to show you two different calculator operations for calculus that you're going to need to know how to do. So the first thing that you're going to need to know how to do is how to graph a derivative on your calculator. Graph a derivative. But the significance to this is you can graph the derivative of a function even though you don't actually know the equation of that derivative. So I'm going to say graph a derivative without knowing equation of derivative. Because otherwise, you're just graphing a function. I mean, just like you graph any other function. But you can graph the derivative of a function without knowing the equation of that derivative. So for example, let's take an example of one that you don't know any rules for how to find the derivative of. Let's say y equals the natural log of 3x minus 5. Okay, we do not know how to find the derivative of that yet. We will way down the line. But I can still graph the derivative of that function. And the way you do it is you go to your y equals and you put in the equation, the original equation. So I'm going to put in natural log 3x minus 5, 3x minus 5. And I don't need to graph that because I don't really care what that function looks like. I want to know what the derivative function looks like. So for y2, I'm going to tell y2 to take the derivative of y1. And in order to get derivative, you're going to press alpha window. And then you see number 3 says in deriv. So we're going to choose number 3. And so that first box that's flashing right now is you're telling the derivative what it's going to be in terms of. So that's always going to be an x. So this means the derivative in terms of x. In the next parenthesis, you're going to tell it what you want to take the derivative of. Since I want to take the derivative of y1, I'm going to put in there y1. Now, instead of typing y1, you could have just typed in natural log of 3x minus 5, but it makes it easier to just say we're taking the derivative of y1. And then this last box here, we're going to put an x because that means we're going to graph the derivative for all x. We want to graph the entire function, not at a specific point, but the entire function. Now, if you hit graph right now, and I'll do like a zoom 6, first it's graphing the original function and then it's graphing the derivative. So something to keep in mind is a lot of times we don't want to see both. So just a reminder, if you want to turn off one, you move the cursor over to the equal sign, you press enter and that'll deselect it because you don't want to delete y1 because you need to know what y1 is in order to find the derivative of it. But that way, now when I press graph, it's only going to graph the derivative. Okay, so just as a reminder, what we did in this situation was I'll say here, step 1 is, I don't want to say graph, I'll say let y1 equal whatever your function is. And then step 2, you're going to choose alpha window. And what number was it? Was it number 3? I forgot. Let's see, alpha window. Yeah, it was number 3. Alpha window, and then choose number 3. Okay, so that's if you want to graph a derivative function even though you don't know what that function is equal to. And the second thing is, what if you want to find the value of a derivative at a specific point? And again, you can always find the value of a derivative at a specific point by plugging that number into the derivative function. So the value of the calculator here is if you're trying to find the derivative at a specific point, if you don't know the equation of that derivative. So we're going to say here without knowing equation of derivative. So let's say, for example, let's go to the one I had up above. If I say f of x equals, well, no, let's take a whole different one. Let's say f of x equals, I don't know, let's go crazy. Sine of x plus 2 all over x squared minus 5. I certainly don't know how to find that derivative. But let's say I want to find the derivative at, I don't know, how about x equals 5? Nope, not 5, because this will be undefined. How about the derivative at x equals 10? Okay, so I don't know what the equation for the derivative is, but I can still find the value of the derivative. Now, you can actually do this from the graph screen, but it's a little more involved. I want to do it from the home screen. So my suggestion is, let me clear both of these out. My suggestion is go ahead and put that into your y1. So I'm going to put in the fraction of, on top I'm going to put sine of x plus 2. Sine of x plus 2. And on the bottom, I'm going to put x squared minus 5. Now I am, oops, sorry, forgot my x. I am going to do a quick check. Is that x squared minus 5? Right. I am going to do a quick check to make sure that I'm in radian mode, because remember, anytime we're doing trig functions, you need to make sure you're in radian mode. Okay, I'm in radian mode. So there's my equation. So in order to find the derivative at a point, we're going to do this from the home screen. So I'm going to go back to the home screen. So I want the derivative of this function. Well, you pull up derivative the same way you did above. So I'm going to say alpha window and choose number 3. So I want the derivative. Again, that first box is x. That's the same. What am I taking the derivative of? Well, I have this saved in y1. So I'm going to say the derivative of y1. And then over here is the point at which you want to find the derivative. If you want the derivative at 10, then you would put a 10 in that box. And when you hit enter, even though I don't know the equation of the derivative, I know that the derivative at x equals 10 is this number. So what I'm going to put here is you're still going to let y1 equal whatever that function is. But then from the home screen, you're going to choose that alpha window. You just want to make sure, so here's what you're typing in, right? Derivative of y1. You just want to make sure that at where it says x equals in that box, that's where you're going to put in whatever the number is, right? So that's the difference on this finding the derivative at a specific point. Okay. I think I will wind that up just so it can be its own